Okay, the GLBP lab topology is similar as SRB and VRB, except I add the two more users 4 and 5 belong to VLAN 40. And on the router 1 and router 2, I need to set up the sub-virtual interface for VLAN 40 at the real IP address and using the virtual IP address 40 and .254. On the router 1, I set up the two more uplinks to the IP2 and use them for the creating the track later. After done the configuration, my expectation user 4 and user 5 receive the different MAC address for the one virtual IP address 40.254. About the algorithm to join the MAC address on the router in the same GLBP group, I use the default round robin. Okay, the configuration on the router, the first I need create sub interface same like SRB or VRB 40 and caps solution doc1q for VLAN 40 and IP address real IP address 192.168 40 and 252 255 and define the GLBP group 40 and follow the virtual IP address this one and 192.168 40 254 and define the GLBP 40 priority for define who is a AVG active virtual gateway. Router 1 is active, so I join priority 120 and this is done for the router 1. Only two commands, right? Okay, on the router 2, create a sub virtual interface 40 and doc 40 and then IP address real IP 192.168 40.253 and set up the GLBP 40 virtual IP 40.253 sorry 254 and by default the priority 100, so let me define the priority for the VLAN GB40 and priority 90. Okay, after I done configuration of router 2, router 1 will inform me the router 1 is the folder 1 and come to the active and the AVG is active also. And let me show a GLBP brief and then we have the three lines. The first line give me the information of AVG with priority 120. Local router is an active router with IP address and standby router is router 2 has IP. Okay, and the last two line had the AVF. One is local router and second is the remote router 2. Router 1 listen the router 2 for the AVF function, and we had the two MAC address. One MAC address is 01 and 02, and we had the value 2A 0.2A. This comes from the GLBP group convert to the hexa. We had the 40 decimal, so convert to the hexa we had the 20A to 2A, and the last two digits come from the forwarder ID, forwarder number. We had the router 1 is 1, so we convert is 01, similar to router 2. Okay, let me check the router 4 GLBP brief and same right. The router 2 is standby for the active virtual gateway. And the last two lines give us information about the AVF, router 2 listen router 1, and by default itself is the active router. Okay, let me show the more information using GLBP. And here we had the GLBP group active, V2 IP rest, by default permission disable, standby IP rest, and we had the two forwarders, 1 and 2. Okay, we have my rest, and the default timer, hello timer 3 seconds and hold timer 10 seconds. Okay, clear, right? And so GLBP, and we had same on router 2 with the Margaret, hello timer, stay standby, edge router, priority, forwarder 1 and forwarder 2. Okay. Okay, let me open user 4 and 5 and check MAC address. My expectation user 4 and 5 is a different MAC address for the same one IP gateway. Okay, so IP minus A. Okay, I did not see the gateway IP here. How about user 5? Okay. Okay, user 5 receive the MAC address is 2801, but router 4 not. Let me disable the NIC and enable again. And then enable. Okay, now the user 4 receive the MAC address 28.2. Okay, and user 5 receive the 28.1. So different MAC address, right? With this MAC we can achieve the load sharing traffic for each user on the same VLAN. So the logic, the router user 4 and send the traffic to router 5, router 2, and user 5 send the traffic to router 1. Of course, in the ISP1, we must set up the routing for the make traffic available to the VLAN 40 in the outside. Okay, let me trace on the route user 4111 and the next hop is 253. This is router 2. Okay, next hop is the 252. This is router 1, correct, right? Okay, so the user 1 send the traffic to the user send the traffic to different router, so then we can load sharing traffic for the user in VLAN 40. It's so different than the SRIP or VRB. Okay, now next step, I need to set up the track on the router 1 for the tracking uplink. And my scenario, if the board of uplink on the router on the interface 2 and 1 down, I should trigger the failover. But if the router had the one uplink down in the port 1 or port 2, I don't need the trigger because user has one available uplink. So the configuration, I will use the resume the track on the router 1. I set up on the video, so I need to create a one track on the router 2. So the first I need create one more track interface 2. Track 40 interface 0 select 2 live protocol, and now I had the two track 10 and track 40. Apply to track to the GLBP for 40 and GLBP 40. Use Y and track 10 decrement 20 same like the track 40 and define the whiting value GLBP 40 Y120 and upper and lower threshold, lower 90 and upper 95, and okay, in my case it's the one the up interface down, my whiting value 100 will minus 20, so now value is 100. This value still upper than 90, so the AVF router still longer to AVF group and has capability to forward the traffic. In the case both the uplink the fade down, so my waiting value is 120 minus 20 minus 20, right? And the value is 80. This value lower than 90, so AVF will trigger failover and the router no longer to forward the traffic user, and router 2 will take care the responsibility to forward the traffic of user in the VLAN 20. If the one of my uplink recovery up again, now the my whiting value is 100, right? 80 plus 20, so this value upper than 20 95, so now router will recovery and forward user traffic again. Okay, let me write configuration, and now I will test the scenario by set down the one uplink on router 1. For example, I set down the router 2 and my expectation user 4 and 5 still use the router 1 to send the traffic because no failover trigger, right? Okay, interface 0 2 and set down and user 2, so still keep back red router 2 router 1 router 2. Okay, let me trace set minus d on user 5 1111, trace set. Okay, use the router 2. How about user 4? Okay, user 4 using the router 1. Okay, so the end user still keep the traffic as normal, nothing change. So let me show GLBP and check what happened. Okay, on the router 1 still had the 2 forwarder, the 1 and router 2. Forwarder 1 and router 1 still stay active on our router, so GLBP. Okay, same right, router 2, listen router 1. Okay, and one more thing, next step I will set down the bot of uplink interface on router 1, and my expectation router 1 is no longer AVF, and router 2 take care on traffic of VLAN 20 or 40. Okay, 1 and shut down, and just a few seconds the router will tell me the group forward the one state change from edit to listen, edit to the listen. And how about router 2? Okay, group 40 forward the one from listen to edit, so now router 2 now forward the edit and forward to edit, so it did not listen the router 1. Itself is a active router for the AVF. Okay, so GLBP brief AUC forward the 1 and 2 Now router 2 will take care every traffic from here end user. Let's check the end user. So what's happened? Okay, so AIP now user 4 still keep the MAC rate of router 1 because we are the redirect timer still valid, right? User 5 now still keep the MAC rate of router 1. It's normal because um, router 2 take care everything function of router 1 include the MAC virtual MAC address. So every request sent from user file to router 2, router 2 can join the virtual MAC address of router 1 if the direct timer still valid, right? Important, I will trace us and determine whether the user join the router 1 or router 2 is the next hop. 111, my expectation user will join the router 2. Yes, correct, right? Okay, 111. Okay, user 4 also join the router 2. Yes, okay. And now I about to enable the one uplink again. For example, I enable the box 2 on router 1 and my expectation router AVF1 will recover the function. So now it will eat the AVF and has capability to forward the traffic. Okay, because the uplink up again, so my track will up and my waiting value is 100. It's lower, higher than the upper threshold. Okay. Okay, so my expectation, the forwarder one stay listen to active just a few seconds. Okay, we had the log from router, forwarder one stay listen to active, perfect, right? And now let me show IRB on the user 4 and user 4 still keep this one. Rest. Okay, let me show GLBP brief and now router 1 come back to the active AVF. How about on router 2 GLBP. Okay, the forwarder 1 stay listen. Okay, forwarder 1 listen and forwarder 2 router 2 active. Okay, everything is come back, right? And now let's try from user 1. Okay, user 1, sorry, user 4 still keep router 2. How about user 5? Okay, user 5 use AVF 5, AVF 1. Okay, I cannot trace to the 111 because I believe something wrong in the ISP 1 routing, but it doesn't matter until now, right? We can determine the user 4 and user 5 can use the both of router 1 and router 2 as a gateway when you user send the traffic. Okay, so with the GLBP we can achieve the loss sharing traffic for the user in the same subnet, same VLAN. This is different than the SRIP or the VIP. Okay, thank you for watching and see you in next video. Okay, like and subscribe my channel, friend. Bye bye.